sublime rhymes like the loaves and the fishes. When I'm spitting this vicious, I'm worse than the pit that don't listen, and you're about to get beaten by one of the best in the business. I'm ridiculous when it comes to these mathematical compositions. Street composer, I'm the rap Latin Mozart, Beethoven, Mixo, Mel Gibson, cause I'm a brave heart. You don't believe me? Stick around when my dogs bark. Take you out 2 by 2 like Noah's Ark. You don't wanna get up on the track like that. Wanna spit on the mic and do it just like that. To a beat that I'm speaking in a way that's unique to the peeps in the street with a medical heat. When I'm living and singing and spitting the venom and giving the sound that ain't nobody bringing. I'm ripping the mic when I'm up in the zone.
Hey guys, Mr. Enyard here. T-Bone, something else, right? Pretty impressive. Today we're going to be going over grade 6, module 5 in Eureka Math, going over how to find area and perimeter of polygons made on a coordinate plane using the ordered pairs as well as using the figure itself. So stick around. Hope this helps. Have an awesome day. All right, everybody. Today we're going to be plotting points on a 4-quadrant coordinate grid, and then we're going to find the area and perimeter of those shapes using a couple different strategies. So this first one we'll do by starting with the ordered pairs, plotting it, and then solving for area and perimeter. And then the next one we will do with the figure already drawn, and we'll find the ordered pairs and then find the area and perimeter. And that should be it. So this is grade 6, module 5, lesson 8 and 9, continued. So let's go ahead and jump right in. So point A is our first one at 4, 6. So we're just going to plot a point at 4 to the right, 6 up. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Right about there. I know that's not perfectly on the dot, but you can see that I went 1, 2, 3, 4 over, 1, 2, 3, 4, 5, 6 up, and that was A, right? And then, so I can name it if I want to, but I don't necessarily need to do that. So then I go to B, which is 1 over 2 up, so right here, and then 1, negative 4, 1 over 4 down. I should be more specific. Those are 1 right, 4 down. So now I have 4 over 8 down. Just right there. And then I have 7 over 2 down. 7 to the right, 2 down. So 1, 2, 3, 4, 5, 6, 7. 1, 2. Okay, and so my question is, what shape do these 5 points create, right? What shape do they create? So let's go ahead and connect them. And I get a strange looking pentagon like this. So how would I find the area and the perimeter of a figure like this? Well, I can tell you right now, perimeter is going to be tough with these diagonal lines that are going to be hard to find the distance for 6th grade math, but there is a way. And then area is going to be a little simpler, but I have 2 options. And so option 1 is cut it up into smaller rectangles and triangles, but with only this one straight line, I could draw one here, and then maybe another one, down from there, but it doesn't really go to a set point, so that's tough. The other option, which I like a little better, is to surround it with a rectangle and then subtract the little triangles that you create from the total area. So I'm just going to use a different color here, and I'm going to draw a box all the way around it, starting at each, corner right there, and then I got to go all the way up to here, and then this goes all the way to there, then this comes down, and that includes this whole side, and it goes down to here. So you can see in the red I've made a rectangle, right? Which will be easy to find the area of. And then I'm going to find the area of each of these 4 triangles created and subtract them from the total, which would leave me just the space inside. So let's do that. So you can see I counted the base and the height, or length and width, whatever you want to call it, since I have 4 right angles. And I got 6 by 14, and 14 times 6 is 84, and that would be units squared. And then I highlighted all that would create. But keep in mind, I don't need this section. I don't need this section. or this one, or this one. I just need this space. So I'm going to have to find the area of these, which is pretty simple since I created right triangles that will clearly have a base, a height, and then I can divide by 2 after multiplying them, and subtract them from this 84 to figure out what's left. Okay, so this looks like a lot, but let me go through it. Okay, here I am. You see me? This is me spinning a beautiful red line. So the total area was over here in yellow, was 84 units squared because it was 6 by 14. Then I went and found the area of this triangle. So I counted its base and its height, 3 times 8. But the area of a triangle is base times height divided by 2. So when I got 24, I divided it by 2, and the area of this triangle is 12 units squared, and I just wrote that in here because I'm getting rid of all these triangles, right? Over here was a 3 by 4, which was 12 base times height, which would create a rectangle, so I divide it by 2 because the area of a triangle formula is base times height divided by 2, and I got 6 units squared. Same thing here was 6 units squared, and this one I got 18 divided by 2, which was 9 units squared. So now I'm just going to take my total area, write it over here, and I'm going to subtract these. So 12 plus 6 is 18. 18 and 6 is going to be 24, and 24 plus 9 is going to be 33. So I'm subtracting 33 square units, and that leaves me 51 units squared for my pentagon. And that's how we can find the area of irregular shapes using ordered pairs on a coordinate grid. Okay, so what about if we had this? They already drew it, right? We don't have any ordered pairs given to us, even though we could easily go 4, 3. For this one, negative 4, 3. For this one, negative 4, negative 3, 4, negative 3, and 0, negative 5. So it'd be really easy. Do we need to draw a box all the way around this and eliminate these two triangles? I mean, we could, but I feel like having a total minus 2 different things we find gives us 4 things to do, when I could just, do you see another way to do it? Yeah, what if we just cut it right there? Because then we have a very clear and easy to find rectangle, right, which we could simply count the sides here, right, at 6. There's our distance of 6, and then we have 8, so that's going to be 48 units squared, right? And then this triangle, the base is 8, and the height, right? Isn't this the height right there? Right here? That's my height. That's 2. So I've got 8 times 2, which is 16, and then it's a triangle, so 16 divided by 2 equals 8. So this would have 8 units squared, and then I can just add 48 plus 8 and get 56 units squared for my whole figure. Now this one, perimeter is going to be kind of tricky as well because of these diagonal lines. So I don't believe you get asked any of those yet because that's not a 6th grade skill. So let's just do one more with all straight lines so we can find perimeter. All right, so for this one, let's assume that this all connects, okay, and that this doesn't overlap and this connects. I apologize. I did my best using the tools, but I didn't do a very good job. So what is the area and perimeter of this? So for perimeter, remember that is the boundary, the border, the outline, the fencing, the how long around, okay, adding up all the sides. So we're literally just going to count all the sides and add them. So I did my work over here of adding together all of these. I started here and went this way until I got back to that. So here's that formula. Just add the sides, and I end up with 58 units. So how long would I need of fencing to cover the outside of this? Would be 58 units. That's perimeter. Now area, since these are all already rectangles, I'm going to split them up here and here and create 3 rectangles, and I'll just call them A, B, and C. Okay, so my area is going to be area of A plus area of B plus area of C to find the total area. So you can see that my area of A was a 9 by 5. 9 times 5 is 45. Then I had a 10 by 5, which is 50. And I had a 5 by 2, which is 10. And when I add those together, I get 105 units squared. So my perimeter was 58 units on the outside. My area was 105 units squared inside. So there you have it. Well, there you have it, guys. That's how you find area and perimeter of polygons on a coordinate plane. I hope that helps. If you have any questions, feel free to leave some comments below. If not, like, subscribe, and have yourself a wonderful day. Keep rocking that math.
Get beaten by one of the best in the business. I'm ridiculous when it comes to these mathematical compositions. Street composer, I'm